Next presentation is a short talk. So yeah, watch out your timer, please. No pressure. All right, so the name is, it is titled CasinoLimit, an offensive data set labeled with MITRE ATT&CK techniques by Sébastien Kilian, who is actually, who is currently, a PhD student at CentraleSupelec. The floor is yours. Oh yeah, this is one of the challenges we have. So let me show you how we do this. So we tried to click here and there, blah, blah, blah. It wasn't working, but eventually we found this burger here. So then you find that there is a sub-menu there, and what else you do with a PDF reader than just putting it full screen? So they had to hide it, very far away. So okay. It's Control L. I didn't remember that. Okay, cool.
So yeah, thank you very much. I'm Sébastien Kilian from the pilot team in Rennes. So I'm here to present some work we did, which is called CasinoLimit, an offensive dataset labeled with MITRE ATT&CK techniques. So maybe some of you have already seen some part of this presentation, so I'm sorry, but I hope I can add more details and more results. And this work was accepted at RED 2025. So we all know that datasets are essential in cybersecurity. They are the basis of many applications, such as CTI, detection, and so on. We distinguish two types of data sources in the wild. They are mostly from either real-world data, which is logs from organizations under attacks, or on the other hand, it can be data that have been created in a controlled environment, usually by scripts. So real-world attackers usually are accurate. However, it's not very scalable and not available, usually for privacy reasons. But on the other hand, we have data that have been generated in a controlled environment. This is less accurate, but more scalable and available. So we'd like to tackle the issue that dataset currently often lacks the diversity and does not really reflect the complexity of real-world attacks. So in more detail, we'd like to collect data with a lot of techniques in them that represents what the attacker can do, then label it to make some sense of it, and finally analyze it to understand what is in our dataset. So to do this, we propose to challenge for the BRAS CTF 2024. So the BRAS CTF is the largest cybersecurity competition in person in France, with more than 600 players. And during this challenge, we plan to collect ODD logs and network flows. So basically, this looks like this. You can see us in the front. We are monitoring the challenge. And in the back, each of the tables represents one team. And we gave each of the team a different infrastructure with the same scenario on it. This scenario is composed of 2 networks, 4 virtual machines, 7 attack positions, and 8 required steps. So in more details, here is a scenario which is to progress in a casino's network in order to remove at the end an entry from a database. So we first gave the attacker the credential of the first machine, then they can reuse it to connect to a second machine on which they have access to a camera. Using this camera, they notice a password written on a node somewhere, but this password is not complete, so they have to brute force some of it to access a third machine, on which they perform a privilege escalation, and then finally they can exploit a website using an SSTI, and they can remove the entry from the database and get the flag. So here is an example of what one of the team did for the privilege escalation team. So this is Team Fantasy. So first they use the SCP tool to transfer the tool to the correct machine, then executed it, and finally they got a root shell as on the Bastion machine. So they did it pretty quickly, in less than 15 seconds, but sometimes it's more complicated. Here is an example for the same step, but by another team. So as you can see, they used 2 different SCP commands, first to transfer the tool, the exploit to a first machine, then to the correct machine. Then they try to use the untar command, which doesn't exist, so they have to look up the documentation of this command. Then they try a few options, and finally got it extracted and executed. So they took more than 10 minutes to do this. So as you can see, there is a lot of erratic behaviors, but every team does not do the same thing for each of the steps. So this is kind of the interesting part of this dataset. So what we get at the end is 25 million system events and more than 1 billion packets for a total of 540 gigabytes of data. Here are some the specificities of the dataset. As I said, there is a lot of attacker profiles. Some are good, some are less good. And there is also some erratic behaviors because players don't usually go straight to the answer. Sometimes they do mistakes, they do the same thing twice. So yeah. And now we need to label this data in order to understand what is concretely inside the dataset. So we chose to label the data using MITRE ATT&CK. This is a classification of techniques and tactics used by attackers during an attack. Most of the label can actually be put automatically. We can simply associate a command to a label, but some will need some human intervention. So here is an example of a ping command. So the naive label would be to set it to remote system discovery. This is because this is the usual use case of ping. However, that's not correct. What the attacker actually wants to do is to check if the machine is connected to the internet, because, well, of course, this IP is running, but so the correct label is actually system network configuration discovery. So this is some human intervention needed to put the correct label on each of the commands. Now, for network logs, we propose a new methodology, which is to extract the network consequences of each of the process and propagate the label from the process to the network flows. So we'll build for each process a request to match all the flows that have been generated by this process. Again, this can be mostly done automatically. So this is the same example for our ping command. We can extract the start of our request by the timestamp of the command. The end of the request is a bit more tricky. We chose to use the timestamp of the next command, but sometimes it's not correct, so we have to check it. The source can be extracted from the host on which the command has been executed. And the target can be found in the command itself. We can simply extract it using regular expressions. So at the end, we have our request that can match the flows. So it looks like this. On the left, you have the system logs, and I've highlighted the ping command. And on the right, there is the network flows. And you can see that we have matched the two correct flows that correspond to our ping command. And you notice that we did not match a flow in between, which is to a different source and different destination. This is a common pitfall in the literature where only timestamps are used, so this flow will be matched. So we designed a tool to perform this methodology. It's publicly available, but basically here in the center you have all the commands that have been executed by the team. In the left, there is the labels that we can add and verify. And on the right, you can see the network request that I showed you before. And on the bottom right, there is the request that have been matched, so we can check what have been concretely matched. And we can see that there is no matching flows before and after that match our request. Now, some application to this dataset. So we can find a typical behavior of in the sequences of tactics used by the attackers. So this automaton represents the sequence of tactics generally done by the attackers. This is interesting because we can see that there is a lot of back and forth between all of the other tactics and discovery. This makes sense because usually before doing something, you have to know what to do. And because the attackers did not have any information on the system, they have to do a lot of discovery. This graph is interesting to compare with other type of attacker, such as automatic attacker, because it will be very different. So this is something I'm currently working on. Another fun application is attribution, because even though we did anonymize all of the data, we can still find and identify some of the players using their habits. So these indicators would be the text editor they are using, the option of a few commands, and also aliases of the commands. So here is an example for the SS command. You can see these two commands by player A, player B, does the exact same thing, but they are different in the options. So because a player, when it does this command once, will usually use the same option that he learned, we can identify them. And on the right, there is a similarity matrix between all the players. So in yellow, you can see that each team is similar to itself, but they are very different from other teams, but it varies sometimes. So now a wrap-up about the methodology. So we create a methodology that is suitable to label a lot of attacker activity with a very high variety of techniques. Also, we have deduced the labels on the network flows from the system logs, and we published a tool to do that. Now for the dataset, we made sure that the scenario is replayable in order to reproduce the results. There is more than 5,500 gigabytes of attacker activity, and we have 114 attacker profiles, which means 114 different instances of the game that have been played. So in our dataset, we saw all of the 14 MITRE ATT&CK tactics and 67 different techniques, which means 67 different types of labels. And there is over 9,000 label placed. And here is the paper. So now some future work. I'm currently working on modeling attacker behaviors. So if you want to talk about it, I'm very happy to do. And I will try to compare this kind of data with offensive model, maybe trained with this data or not. Also, a bit of a teaser, we are doing the same thing this year at the Brest CTF. So if you are in Rennes for the Brest CTF, please try this challenge. It will be very fun, I promise. And thank you very much for your attention.
C'est bon, on a 5 minutes de questions, mais on n'est pas obligé de prendre.
Thank you. Question?
Hi, thank you for your talk. I have a quick question. Have you assessed that CTF players' behavior are the same or are less similar that a real-world attacker we can observe in the wild?
Yeah, of course, there is a lot of differences between real-world attackers and CTF players. And yeah, of course, we did not catch this behavior. So yes, it would be interesting to compare this graph with what an attacker can actually do. But yes, it's one of the major pitfalls of this kind of work, and can be upgraded. Yeah.
Okay, thank you.
Yeah, I have a question. Is your approach easily scalable to other CTFs or challenges in different fields or on different setups? And could you provide a general framework or something that CTF organizer could use?
Actually, some CTF organizers are already doing it with their own framework, but I'm placing myself at the dataset analysis level and not really at the collecting level. Everyone has its own collecting pipeline. Here is ours, but some of them have others. So yeah, we can propose our method to collect the logs, but what's really interesting is, for me, it's the end of this pipeline where I analyze the things. But yes, of course, we can also implement. We also provided the code to collect the data.
And a quick follow-up. So if a CTF uses a different collection pipeline, is it easy to plug into your data collection and analysis if it's a different collection pipeline?
So yeah, we used common tools at the basis of it, like Elasticsearch. So I think yes, one of the major problem would be the entry, well, the host part, where sometimes the logging mechanism can be different from Windows, from Linux, from other types of things. But it probably will be doable because of these standard tools, yes.
Thank you.
Thank you for the talk. Most of the time, what you do during a CTF is nice, it's an attack, but it's not what you do in the real world. If I want to attack a company, what I learn from CTF is totally useless. Do you plan to do CTFs that could be close to what happened in the real world? I mean, to deploy a real, well, not a real, but something close to a real company networks with some common vulnerabilities. For example, use NTLM hash and see what the attackers could do during a CTF which is not a challenge, which is not real to what really happened in reality for attacks.
Yes, another approach to CTFs is to use honeypots. So you can also pipe this pipeline on honeypots that are publicly available in the wild. So an attacker could scan it and probably connect to it and try to do some things. But yeah, it's harder to attract attackers on honeypots. Well, a fun fact, one of our tests recently for the next challenge has been compromised by an outside attacker. So it's actually possible, but they usually don't want to share what they want to do easily.
It's okay? Okay, so thank you. Thanks a lot. The last presentation for the session now.